So we get a picture like this. Okay, down in the left-hand corner there. See the little red arrowheads over there? I'm making them parallel. Now, before we get into this other stuff, we need to talk about the word postulate up there. The word postulate means something that you just take to be true. You accept it as being true. We're not going to prove it. You're just going to have to trust me on this one. I wouldn't lie to you. This must be true. Okay. Now, once we've established that, we can say the following. If you have two parallel lines that are cut by a transversal, then the corresponding angles are always congruent, which is shortened over here. Parallel lines, the arrow means implies that the corresponding angles are congruent. Okay? Easy. We're not going to talk about it because it's a postulate. We don't have to prove it. We're just going to move forward from there. We need to do that with at least one of the theorems here so we have a basis to operate on. Everything else is based on this simple postulate. From now on, we switch to something called the theorem. Okay? Are we good on this one? Okay. Okay, now we good? How about now? Tommy, good?
Almost there. Oh, dang it. I just need to get the little parentheses on the bottom.
Parentheses on the bottom.
The lines in the arrow. C-O-R-R.
Did you just say Pac-Man?
Yeah, right. That's what it is. It's Pac-Man's. After C-O-R-R dot.
It's like
I see a
Pac-Man.
Pac-Man. It's like Pac-Man and then crossed by the S.
Urge him. There's no Pac-Man on that
It
screen.
is, look. Pac-Man.
Like the triangle.
It's like his mouth. Or I could say
Well,
alligator.
yeah, but that doesn't make it a Pac-Man.
No, but alright, it looks like an alligator, and so looks like it's like they have two God, no, it's a Pac-Man because I don't know. Alright, it's fine. You don't have to agree. What? Think in my head. What's that symbol called?
The angle.
That's called an angle. That symbol. Alright. Alright, next one.
Because give me a minute. Because if the theorem was parallel lines implies corresponding Pac-Mans congruent, that would make no sense whatsoever. Are we all in agreement there? Even though that would be a postulate and you accept it as being true because it is a postulate, I would not expect you to trust me on that one. That would be the point where you would realize I'm lying to you. About the Pac-Man? I don't know anything about whether or not corresponding Pac-Mans are congruent. I don't know what makes Pac-Mans Pac-Men?
No, it's Pac-Man's because you got it
Pac-Man?
yes. See,
It's
'cause
Pac-Man, so if you have more than one, you would have Pac-Mans.
Yes, exactly.
Right. Okay.
Or like possessive Pac-Man. It's Pac-Man's.
Yeah, like his line.
Yeah.
What is that? That's Pac-Man's apostrophe S.
Yeah, that's what that is right there.
Right, but if you have more than one of those, you have Pac-Man's, no
Yeah.
apostrophe.
There is an apostrophe though.
Right, which is a little confusing.
So it actually can't be Pac-Man's.
It's Pac-Man's roughly equals the sign.
It looks like it's shady. Like,
Okay, let's move on. Now we switch to a theorem. So forget about everything else. Let's talk about the word theorem. A theorem is something that which we can prove. In fact, you're going to prove it in a second. Postulates you take for being true. You trust me on that one. I wouldn't lie to you. Theorems we're going to prove. Okay, so here's the first theorem. If you have two parallel lines that are cut by a transversal, this implies that the alternate interior angles are congruent. Okay? In other words, angle 3 and angle 4 have to be congruent. Now the question is, why is that true? And to make the explanation a little bit simpler, let me label the other angles up there. I think we're good here. No, we're not. Why isn't my pen working? Nope. Back one. Okay. 1, 2, 5 alpha, beta, and what's that last one? Gamma, or fishy on his head. Okay. So why are angles 3 and 4 congruent? Peter.
Notice 2 and 4 are, and then 3 is a vertical angle 2.
Let's give it up, kids. Everybody follow that? Do it again.
2
Hold on, let me change colors. Go.
2 and 4 are equal.
Because?
Uh,
I just changed colors here.
the transversal. Oh,
It's that previous slide.
Yeah.
Right, parallel lines implies corresponding Pac-Mans are congruent.
yeah.
Okay, good.
And then 2 and 3 are vertical. So then 3 and 4.
So let me see if I understand this correctly. You're saying 3 is equal to 2, 2 is equal to 4, therefore 3 is equal to 4. Bonus question, do you know what property that is?
No.
Do you want to guess for a possible prize? Wouldn't hurt to guess. I mean, what's the worst that could happen? You get it wrong?
Postulate.
I'm sorry?
Postulate.
Postulate, no. Thank you for guessing, though. Good try.
It's okay.
Okay. Everybody good with his proof? You follow that? Not the only way to do it. Could have done it a different way. I like his method better, but you could have said beta and 3 are congruent. Beta and 4 are congruent because they're vertical, and 3 is congruent to beta, beta is congruent to 4, so by that weird theorem that we haven't named yet, 3 and 4 are congruent. Same results. All that does is justify that this statement is true. We just proved it. Because it's a theorem, we should be able to prove it. We just did. Everybody's happy. Let's move on to the next slide. Any questions on that? Awesome. CIA. They are not congruent. They are whoa. Why'd my arrow drop way down there? This arrow is supposed to be up here. Parallel lines implies CIA are supplementary. So. Can you see those?
Yes.
Ish?
Yeah.
What does that mean?
I mean, I can't see it well. I can see it.
You can't see it well?
Go on.
You can see it ish?
I can see it.
You can.
See it.
You're killing me today, Tom.
I don't understand. There you go. Now it's pretty.
Well, that was my goal. Why are 5 and 6 supplementary? I put numbers in there so we could talk about them. Tom?
5 and 6 are supplementary because 5 and 3 are supplementary and 3 and 6 are congruent.
Perfect. Bonus question, why are 3 and 6 congruent?
3 and 6 are congruent because 3 and 2 are congruent, and 2 and 6 are congruent.
Let's go back to my bonus question. What theorem states that 3 and 6 are congruent?
The one we just wrote down, but I forgot to write it down. Can you go back to that?
Somebody help him out?
AIA Theorem. AIA
Theorem.
AIA Theorem.
Theorem,
How do you
good.
say that? AIA Theorem.
AIA theorem.
Oh, I did write it down.
You're killing me. Parallel lines implies alternate interior angles are congruent. 3 is congruent to 6. 3 and 5 are supplementary. You put 6 in for 3, and sure enough, 5 and 6 are also supplementary. Thank you, Tom. Nice job.
Thank you.
No, thank you. Please. No, oh, you're welcome. Why did that go away? My pen just got disconnected. I love technology. I'll just keep tapping it until it fixes itself. There we go. Go back over here. Now we can click AEA. Those bad boys are congruent. I don't think we need to beat a dead horse here. We can just, does everybody understand why, or see the possible reasons why 7 and 8 would be congruent?
Yeah.
Okay, good. You do some vertical angles, some corresponding, some alternate interior, some alternate, or some consecutive interior, whatever you want to do, but pretty good to go. I think the one I forgot again was CEA. What would be the relationship between CEA angles? Supplementary or congruent? Yeah, they're supplementary. Okay, so something to help you, we'll come back to that in a second. Something to help you would be this picture here. Let's see if I can get my pen to work again. Parallel lines cut by a transversal. Let's start with all the angles around here. How big is that angle? Why?
That's
Vertical angles. How big is this angle?
150.
How is that again?
115.
115. Why?
Supplementary to 65.
Supplementary to 65 on either side. How big is this angle?
115.
2 reasons why that's 115, please.
Vertical to 115 and supplementary to 65.
Outstanding. Nothing new there. We did that already back in chapter 1. Now, how big is this angle? 65. Give me a couple reasons why that angle is 65. Go ahead, Tom. You're like the shell answer man today.
Yeah, I am.
Uh-huh.
Because the other angle is 65, the one below it.
And what kind of angles are those, Tom?
They're congruent. I don't think that was right.
They are congruent, yes, but what pair of angles are they?
They're the CIAA.
Tom, when you're done eating an apple, what are you left with?
They're core angles. No.
What letter comes after R, Tom?
S.
S. And what do you call a small body of water? What do you call a small body of water? A small body of water.
A pond.
What sound does a bell make?
Ring.
What kind of angles are these two then? Oh my God.
Corresponding.
Corresponding!
Okay.
Why else is that 65 degrees?
Okay.
Alternate exterior to this 65. Why else is that 65 degrees?
Exterior. Yeah. All
What kind of exterior?
CE, right? No.
Yes, CEA,
Yes.
consecutive exterior. Good. How big is this angle?
115.
115. Corresponding, alternate exterior, supplementary, blah, blah, blah. 115, 65, hot diggity. What do you notice now that we're done with all 8 of those angles? Well, they're not the same, but
It's the same shape. No, they're not shape. So I'm done.
you're done? I don't believe it. I think you got more in you. Notice there's only 2 different angle measures up there. 65 or 115. No other possibilities. Most of the time, one of those angles will be acute, the other one will be obtuse. That information will help you solve these problems. Okay? It's pretty much, if you got acute angles in this picture, all the acute angles are going to be equal to each other. All the obtuse angles are going to be equal to each other. All the acute angles have to add up with the obtuse angles to give you 180 degrees. Okay? So if you solve the problem and you get 35 up here, 45 down here, 120 over here, and 115 over here, you did something wrong. Go back and figure out what you did wrong. Okay, let's go back to this guy then. I don't even know if you have to write this down. Let's talk about it first. You got 2 parallel lines. You got a transversal that creates a 90-degree angle, also known as perpendicular. Is it obvious that all of these are right angles?
Yes.
Hot diggity. Let's move on. We're going to transition then from all the theorems with the parallel lines to solving some algebra problems. And I've got 4 tips to help you. That's supposed to be a guy, but I put a black figure on a black background. That's why I never went into art. Figure out which pair of angles you have. Are you talking about vertical angles? Are you talking about supplementary angles? Are you talking about corresponding CIA, CEA, AIA, or AEA? Once you know that, then you should know the relationship between those angles. Alternate interior angles, for instance, are equal.
How does he not have bones in his hands?
It's an industrial accident. I'd rather not talk about it. He's very sensitive about it. You'll never see him wave. Usually just has his hands in his pockets. Then you're going to decide if you set those values equal to each other or add them up and set them equal to 180, because that's the only 2 possibilities. The angles are either congruent or they're supplementary. Step 3, solve the equation and find the variable. Okay, whether you're solving for x's or y's or z's or q's or smiley faces, whatever. And most importantly, answer the question. Okay? Sometimes I will just ask you for the variable. Sometimes I will ask you for a value of an angle. Sometimes I'll ask you for both. Depends on the problem. Okay? So let's put that in motion and see how it goes. Okay? Don't be sorry. It's okay. It's your learning. I know this already. So, it's a defect I have in my buttocks. If I swing my legs, I make them crack. It's really embarrassing.
Okay.
Thanks for pointing it out. I'm never recovering from this. I thought I had it under control, now it's come back. Are you good?
I am.
You are, so. Okay, for this problem, I used the 4. That's not 4 degrees. That's just the name of the angle, because I was too lazy to put all the letters in there. So that's angle 4. Find x, find the measure of angle 4, and then tell me what theorem you used. Which of the previous slide theorems did you use to solve this problem? Don't be bashful about busting out those calculators either. Again, don't be bashful about getting out those calculators. See if you see some of you trying to do the math by hand. Make your life easy. Use the technology. Other hand, high five on your other hand. Oh, that's a low five. But what if you can't have an underhand high five? Because it's no longer a high five. By definition, a high five has to be high. Well, that's different. That's not what you were asking for. That, I would accept that as a underhand high five. Correct. I'm with you. Now we're getting into a gray area. Very technical.
It's like
Where's the high five? think probably here would be the line. So this is a medium file. So this is a medium file. Right, and up here, and that's a high file. And this would be a low file. One of us has to decide.
No, we can do it.
We can't
both.
both.
Yes, we can.
Oh, we go down, yeah, but you can't, once you go perfectly, you can't. You go like this. No. You go, and I go, that's not, that's weird.
I can't. I thought it.
Somebody has to commit to flipping over.
Okay.
I think, or who's flipping over?
Oh,
You're flipping.
yeah,
No, I flip.
Can you flip?
Right, and then that would be. But then if you come up, that, right, so that'd be an underhand high five.
Okay.
Sorry, we had to get that squared away. What's X?
20.
20, good, Y. What'd you do with those two angle measures? Add them up, set them equal to 180. This one's obtuse, this one's acute. Even if you weren't paying attention on the last 10 slides, you don't remember the theorems, you can still recognize that an obtuse angle and an acute angle cannot be congruent. You have to add them up, set them equal to 180, solve for X, you get 20. You could plug it back in, but automatically you would know that angle 4 is 125 because this guy's 125. So let's start with this. What kind of angles are these?
They're
Yes. What pair of angles are these? Paige? What kind of exterior? Consecutive or alternate? Consecutive exterior. Very good. What kind of angles are these? Corresponding, right. It might help if you look at it like this so that you can see them, or you can go like this. Whichever way works for you. Okay. I can't really turn the board. You might be able to turn your paper. Good. Any problems with example 2? Example 3. The directions are wrong. I don't care. There is no angle 3. Just find X and Y.
Why is there a red number 33?
sorry.
There's red,
I
there's
see
red
it.
numbers there.
What?
Five number 3 by the yellow. It's like,
Oh, I see it too.
Oh, yes.
Where is it? Oh, now I see it.
That's really weird.
no, it's 83, I think.
Or 38.
No, it's just a reflection. It's
Yeah.
three.
Example 3. It's like on the black.
Yeah,
It's
I
like
know.
green. It's like maroon and yellow.
You could like,
No,
and with
next
the E
to it,
too, you can
there's
see
like
like
a
that
little
thing
like
with the
shadow
E.
of red.
I bet it's mental. I bet it's mental. It's like, it's not as small as it's saying it is.
Now we can see it for everything on the board.
You still see it on the paper?
Whoa.
Oh.
It's speaking to us. Translate for us.
Still there.
Yep.
Why there's only 1 3?
No, it's
Change for the.
There's only 1
oh, now it's only
What kind of angles
one. Faded.
are these two?
There you go. Supplementary.
Good. What pair of angles are they? Consecutive or alternate? Alternate. Interior or exterior?
Exterior. No.
It's a trick question. It's none of the angles we've talked about. Okay. This is not one of the pairs we've talked about. Okay. It's something weird. But the important part is that Mark realized, and probably the rest of you realize, these two things are supposed to be supplementary. So we get 9x plus 12 plus 3x is equal to $1.80.
Oh.
So what's x?
14. Right?
I don't know.
1.
14?
Yeah.
Who got 14? We're going to go with it. How do you find y then, Ryan?
You do 3 times 14.
42.
Sure. And then you add that to 4y minus 10.
Creepa, lose the iPad and stop making whistling noises. She does again, hit her in the back of the head. With her iPad. Okay, that way we take the iPad away from her and we get her to stop all at the same time. I'm sorry, Ryan, for the interruption. Back to you. So we got 42. That's where we left off, right?
Yeah.
Okay, good.
And then you add that to 4y minus 10.
So 42 plus 4y minus 10 is equal to?
180.
Good, because they're supplementary. And y turns out to be? And y turns out to be? This y here is how much?
37.
37? Who said that? Thank you, Jill. 37. Is she right?
Yes.
You guys don't know. Whatever. We're just moving on. Hold on, I can check. Good job. Thank you. Appreciate it. Okay, solve that one. Now find angle 3 along with finding x. Because you'll need x to find angle 3. Stop it. Okay. I'll come back. Okay, I know some of you are still working, but I don't want to run out of time. What kind of angles are... Great, stylus is disconnected. What kind of angles are these?
Alternate interior.
Alternate interior. And what's the relationship between alternate interior angles when the lines are parallel?
They equal.
They equal.
They're equal, so set the two equal. Let's see if my pen is working again. Setting the two equal, you get x squared is equal to 2x plus 63. Then what?
Squared.
No,
Square rooted.
no.
You subtract.
Subtract 2x plus 63.
Yeah, move everything to the other side. X squared minus 2x minus 63 is equal to 0. Now what? Factor. Two numbers that multiply together to give me negative 63 but add together to give me negative 2 would be negative 9 and 7. So therefore x is equal to 9 and negative 7. Done with the algebra. Now the geometry. Do they both work?
Yes.
They do?
No.
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 They don't?
No.
No.
Well, I got yes.
Yes, what?
That they.
Yes, they both don't work?
They both do work.
No, they don't. Yes, both work.
They both do work.
Both of these answers work.
Yes.
Are you sure?
Yes.
You're sure.
No.
No, you're not sure. Or no, they both don't work.
They both work. Yes, I'm sure.
No. Yes. Sorry. I'm not gonna talk over it.
81.
Yes. That equals 81.
81. I agree with you that the 9 works.
Oh. Well then, 49 if you put it.
49, right? Negative 7 squared is 49. Uh-huh.
And then it's 49 if you put it in.
Oh, sure enough, look at that. It's 49. Hey, look, they both work. Good. That's what he said.
Oh.
Now, how do we find angle 3?
You just subtract.
Ben?
Because the 81 is supplementary to
99.
yeah. So it's
Und? That's German for and.
What do you mean? What else?
That's what I'm asking you. What else? Armin, how many answers?
There's 2.
Oh. So 131.
2 answers to this problem. 99 degrees and 131 degrees. What did we use? We use alternate interior angles and supplementary angles. And again, here's a situation where we solve the quadratic, both answers work. Doesn't always have to be that way, but that's why it's important that you check them. What you're checking are angles that are, mainly the biggest problem you're going to run into is when they're, when you get negative answers. Last problem, or last situation, is something called a crook problem using an auxiliary line. So I'll show you real quick how to solve these. An auxiliary line is a line that you can add to any diagram. In fact, I'm going to add my auxiliary line right here. This is called a crook problem because this line is bent in a crook. It divides this line, or this angle 1, into 2 separate angles. This one and this one. We'll call the top one alpha and the bottom one beta. Alpha and beta are not equal. That's a big mistake that people make. It doesn't bisect the angle. It just chops it into 2 pieces. How big is alpha?
62 degrees.
62 degrees because it's alternate interior to this angle. These 2 are equal. How big is beta?
36.
36. Why, Mark?
Because if 36 plus 144 is 180 and they're supplementary.
Consecutive interior angles. Angle 1 is made up of the 2 angles of alpha plus beta, so therefore angle 1 is equal to 62 plus 36, which is 98. Okay, these pop up all the time, and again, they're called crook problems. This can bend in more than just one spot. You might have a crook problem that looks something like this. That'll be fun. Draw an auxiliary line in both of the crooks, and then do a bunch of alternate interior, consecutive interior, whatever it takes to find those angle parts. The most important thing to remember, is number 1, you can draw the auxiliary line, and number 2, it does not necessarily cut this angle in half. It cuts it into two parts, but those parts are not necessarily equal. Okay, day 4, I'll unlock it in a second. Any questions? Awesome. Spend some time going over the homework tomorrow.